Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 9-4 on Symmetry. This is all the vocabulary and important concepts that we're going to cover today, so make sure these go into your notes. To begin with, the concept of symmetry. A figure in geometry has symmetry if there is an isometry that maps the figure onto itself. So remember that our isometries are translations, which are slides, reflections, which are flips, mirror images of themselves, or rotations, which are turns. So this butterfly here has reflectional symmetry because one side exactly mirrors the other. And this image over here has rotational symmetry because if you rotate it about an axis, it ends up mapping itself back onto each other. So again, reflectional or line symmetry. A figure has that symmetry if it's a reflection of the figure. So it's always a mirror image of the other half. So here's our butterfly again, remember, it's a mirror image. You can have more than one line of symmetry. This kite here has one, and this triangle has one, but this hexagon here in the middle has many. And an object may have more than one line of symmetry there. And then as you notice, the S has no symmetry. There is no line that you can go through that makes the S a mirror image. The H has two, the A has one, the P has none, and the E has one. So over here on the right, we see squares have 4 lines of symmetry and rectangles have 2. Rhombuses also have 2. Kites always have 1. Isosceles trapezoids always have 1. Regular trapezoids, non-isosceles trapezoids, have none. Parallelograms have none. Equilateral triangles have 3, and isosceles triangles have 1. In point of fact, this right down here is a very important concept. In regular polygons, which means they have equal angles and equal sides, the number of lines of symmetry is always equal to the number of sides in the polygon. Rotational symmetry happens when an image or a figure can rotate or turn and map itself in some rotation that is 180 degrees or less, also known as like a partial turn. It always rotates about a point, not about a line. And so each of these patterns here have rotational symmetry. And how you solve the degree of rotation is you figure out how many different pieces there are, so to speak, and then divide the whole thing from 360. So 360 divided by the number of pieces. So 1, 2, 3, 4, 5, 6 pieces here. So each piece is 360 divided by 6. So that figure has a rotational symmetry of 60 degrees. Our last kind is point symmetry, and you won't see this as frequently, but that happens when every point has a matching part in the same distance from a central point, but in opposite directions. So point symmetry is always, again, around a point and the same distance from that central point, but in opposite directions. It usually has 180 degree symmetry. Let's do some of your homework. This question wants us to match the following figures with a number of lines of symmetry. So for this isosceles trapezoid over here, we have one line of symmetry that goes through the middle here that makes the left side and the right side equal to each other, mirror images of each other. For a square, we have many more. So for a square, you can do the diagonals here and here, or you could go through the top, or you could go through the side. And I didn't draw those very well because I was going fast, but it ends up having 4 different lines because it has 4 sides. And then for the J, notice there's no way that we can split this that's going to make a mirror image of itself. So this one actually has 0. This one is asking for the angle of rotational symmetry for this shape that is a star here, shape number 8. So again, we need to count the points on the star. 1, 2, 3, 4, and 5. And then remember that there are 360 degrees all the way around. So 360 degrees divided by 5, which is 72 degrees of rotational symmetry. And then our last one today, answer questions about the following 4 shapes. Imagine these shapes in 3D like the actual object instead of an image on a screen. So which of these objects has rotational symmetry or turns around in 3D about a line? So if we took the football helmet first, if you look at the front of a football helmet and then turn around and look at the back, those are not mirror images of each other. One has a cage here in the front and the back does not. If we take the teapot, notice we have, the handle and the spout, and those will not be mirror images of each other as they turn around. The hat, however, as it turns around, the beanie, the left side and the right side will be exactly the same. The front and the back will look exactly the same as it turns around. So the hat is definitely a yes. And then the hairbrush, as it turns around, one side, of course, has all the bristles and the back side does not. So the answer for this question is only the hat. Good luck, everybody. I hope you guys all do great.